Okay, I'm back. Hi, class. Today what we're going to do is just cover some of the things that are in both section 1.2 and 1.1, and they were things that I didn't get to, so I'm just going to do short little videos of little sections, so you can watch whichever one you need. So the first one I'm going to do is what's called eliminating fractions. So you can do this only when it's an equation. So what I mean by that is when you see an equal sign and you have fractions in the equation, then you know you can eliminate the fractions. If there is no equal sign, then you just need to use the techniques to add fractions by getting a common denominator and so on. So this only works when you're eliminating fractions with an equation, which means you have to have an equal sign. So let's get started. Okay, so this is the type of equation that I'm talking about. There's an equal sign, right? There's an equal sign. It also has fractions within the linear equation, what you're going to solve for. We have an x to the first power. That means we can solve it, and we're going to find out what that x is. The whole purpose in eliminating fractions is to get it to the point where you don't have to deal with the fraction. You can get it to a simple one-step equation. So what's nice, one or two-step equation. So what's nice is you're going to look at this and you're going to go, all right, what's the one number? And it doesn't have to be the lowest number. So this isn't like finding the least common denominator. It's the same idea, but all you need is what's the common denominator, any common denominator. So what some people do is they look at it and they go, okay, I can find the least one. Others will look at it and go, all right, if I don't see the least, I just multiply the denominators. So if you notice this 4, whenever you have a whole number, it's actually, we can write it as a fraction as 4 over 1. So just keep that in mind when you're dealing with fractions. So what you're going to do is you're going to go through and you're going to multiply every single term by the exact same number. Well, what this does is it allows us to change what it looks like, but it doesn't change the value. It would be like if I had 5 people in the room and I gave them each $10, they all have the same value. It doesn't change how much one has over the other. They all have the same value. If I gave 3 people $5 and 2 people $10, now they're different. So that's why whatever we do it across the entire equation. It changes what it looks like, but it doesn't change the value. So what we're going to do is we're going to look at the denominator. I have 2, 3, and a 1. And I know that the one number that 2, 3, and 1 will go into is 6. So it's the common denominator. Also, I can just go 2 times 3 is 6. So you can do it either way. If you see it right away, use it. If not, just multiply the denominators. So what I'm going to do is I'm going to do this in red. What I'm going to do is I'm going to multiply every single one of these by 6. Now notice I'm doing 6 over 1 just because I'm having to deal with fractions. Okay, you can multiply just by 6 if you prefer, but that's what I'm doing. I'm multiplying every single term by 6. Okay, so what happens is now I'm working with fractions. So I can cross cancel. So the 2 goes into itself once, the 2 goes into 6 3 times. The 3 goes into itself once, the 3 goes into 6 twice, and then here I'm just multiplying because there's no canceling to do. Well, now I'm going to multiply. So I just divided, and now I'm going to multiply. So 3 times x is now 3x. 1 times 2 is now 2, and 4 times 6 is 24. So again, just to reiterate, I find one number that all the denominators will go into, and I multiply every single term by that one number. Once I do that, now I have a straight two-step equation, and this is very easy to solve. You get rid of your plus 2 first by subtracting 2. That cancels that. I end up with 3x equals 22. Now this is a one-step equation. I'm going to divide both sides by 3. That cancels, and I end up with x equals 22 over 3. And you can leave it top-heavy. That's completely okay. In my math lab, if it says to write it as a mixed number, then you'll have to change this to a mixed number. But otherwise, I'm completely okay with you leaving it as an improper fraction. All right, let's try another one. Okay, so again, we have an x, we have fractions, and we have an equal sign. We can eliminate the fraction, all right? So what's one number that 5, 2, and 3 will all go into? Well, this is a good example of, instead of wasting time thinking about what's the one number that all three of those will go into, I'm just going to multiply them because that's the easiest. Again, I don't need the least common, I just need a common value. So 5 times 2 is 10, 10 times 3 is 30, so I'm going to multiply every single term by 30. And it's all multiplication. Okay, now I'm just multiplying fractions. 5 goes into itself once, 5 goes into 30 6 times. 2 goes into itself once, 2 goes into 30 15 times. 3 goes into itself once, 3 goes into 30 10 times. And now I multiply. 6 times 3x is 18x. 15 times 1 is 15. And 2 times 10 is 20. Right back to a straight equation. It has the exact same value as this fraction, the original fraction, but now I have it written in just a standard whole number format. Okay, same value, just looks different. So now I'm going to solve. So I'm going to subtract 15 from both sides. That cancels. I end up with 18x equals 5, and then I'm going to divide both sides by 18. So remember, whenever you're solving for a variable, the goal is to get the variable all by itself, and that's eliminating fractions.